They speak of the arrival of a space object 100 times bigger than 3i Atlas.
In the vast ocean of space, a green light drifts silently through the dark. It is Comet C/2025 R2, known to astronomers as SWAN.
Astronomers in Hawaii have captured the first close-up image, with scientists not knowing where it came from.
A wandering fragment of ice and rock that has suddenly ignited with strange brilliance. From the depths beyond Neptune, it races inward toward the warmth of the sun, leaving behind a trail of glowing gas that stretches for millions of kilometers. But something is off. Its light flickers and flares as if alive, reacting to forces we cannot see. Scientists are watching closely, because sometimes the universe sends warnings disguised as beauty.
An amateur astronomer noticed something unusual in solar observation data, a faint smudge moving through space. That smudge turned out to be a brand new comet heading our way that we're now calling Comet R2 SWAN.
The ominous arrival. The story of Comet SWAN begins in September 2025, when scientists studying solar activity noticed something unusual in data from the SOHO spacecraft. Its onboard SWAN camera, designed to observe the sun's hydrogen emissions, detected a faint, moving glow. At first, it appeared to be a routine solar artifact, but over the following days, astronomers confirmed it was something far more intriguing: a new comet emerging from behind the sun, brightening with unusual speed. By late September, this ghostly visitor had reached a magnitude between 5.9 and 6.8, to bright enough to be seen with ordinary binoculars under dark skies. A green haze surrounded its nucleus, shining against the blackness of space, and its tail stretched across a region nearly 5 times the width of the full moon. Experienced skywatchers quickly realized this was no ordinary comet. Unlike typical icy bodies that follow predictable brightening patterns, SWAN's luminosity surged erratically, its tail rippling as if stirred by invisible waves. It was an unpredictable newcomer from the outer solar system, behaving in ways few had ever recorded. As scientists gathered data, one question began to echo across observatories. What exactly was happening inside this mysterious green wanderer? And the weirdness and the threat. As the weeks passed, Comet SWAN began to behave in ways that puzzled even seasoned astronomers. Its brightness surged without warning, sometimes doubling in intensity overnight. Instruments detected strange fluctuations in its ion tail, suggesting powerful and with streams of charged particles from the sun. Some experts suspected that bursts of solar radiation were triggering sudden jets of gas and dust, causing the comet to flare like a flickering torch in space. Others wondered if deeper processes were at work, perhaps the cracking of ancient ice pockets buried within its nucleus. Then came the unsettling part. When comets behave erratically, they sometimes break apart, scattering debris across their orbital path. History has shown that these fragments can later intersect Earth's orbit, creating spectacular meteor storms or, in rare cases, impacts powerful enough to cause local devastation. If SWAN were to fragment, even slightly, its trail of rocky shards could drift dangerously close to our planet's path. In a year already filled with unusual celestial activity and multiple comets visiting the inner solar system, SWAN's behavior seemed less like a random spectacle and more like a cosmic wildcard. Was this merely nature's fireworks display, or the quiet rehearsal for something far more serious? Unraveling the mystery, background, and discovery. The story of Comet SWAN's discovery began quietly, hidden in streams of digital data from the Solar and Heliospheric Observatory. On September 15th, 2025, a faint, luminous streak appeared in the SWAN camera's images. At first, it went unnoticed among the usual solar artifacts, but a few vigilant astronomers spotted something unusual. The light was moving steadily across successive frames. Within days, ground-based observatories in Namibia, Chile, and Australia confirmed it was a comet emerging from behind the sun's glare. Calculations soon revealed an orbit that stretched far beyond the planets, taking roughly 22,000 years to complete one journey around the sun. Its path was highly elongated, suggesting it came from the distant Oort cloud, a region filled with icy remnants from the birth of the solar system. Unlike interstellar visitors such as 3I Altas, which arrive from beyond the sun's gravitational reach, SWAN was still a child of our own star, bound to return someday after another vast cycle of time. Yet its orbital inclination and direction hinted at a different origin story, one that might trace back to ancient stellar nurseries. Astronomers realized this comet could carry chemical secrets from a part of the galaxy rarely sampled before. Early observations, when the first telescopic images arrived, Comet SWAN was already unlike anything observers expected. Its nucleus glowed an intense green, a telltale signature of diatomic carbon molecules fluorescing under sunlight. Around it, a faint blue ion tail extended away from the sun, shaped by solar wind. Amateur astronomers from Africa to South America began to share time-lapse images online, revealing a constantly changing shape, as if the comet was alive and restless. For casual skywatchers, SWAN became a spectacle. Under dark skies, it appeared as a soft green smudge low on the horizon, easy to find through binoculars. For scientists, however, it presented a puzzle. Most comets brighten gradually as they approach the sun, but SWAN's luminosity rose in uneven bursts, suggesting explosive jets of gas breaking through its surface ice. Each surge released clouds of dust that expanded rapidly, reshaping its coma and tail in unpredictable ways. At the same time, another comet, C/2025 K1 Atlas, was crossing a nearby section of the sky, creating a rare dual comet event visible from parts of the southern hemisphere. For the first time in years, two bright travelers were visible together, racing toward the sun on different paths. Yet, among them, SWAN stood out for its erratic glow and strange, shifting form, hinting that something extraordinary was unfolding deep within its frozen heart. As the comet continued its journey toward the sun, a pattern of instability began to emerge. Observers noticed that its brightness no longer followed any predictable curve. One night it would appear dull and diffuse. The next, it would surge in intensity, glowing with a strange, almost electric hue. Astronomers compared notes and realized that the fluctuations were not caused by viewing conditions or atmospheric distortion. Something inside the comet was changing, and fast. Images captured by automated telescopes showed ripples running through its tail, like waves traveling through a stream of smoke. These ripples appeared shortly after a burst of solar activity, suggesting that SWAN might be reacting to the sun's powerful magnetic fields. Some speculated that the comet's outer crust was cracking under the stress of solar radiation, venting gas and dust in violent bursts. Others thought it might be rotating unevenly, exposing new volatile surfaces to sunlight each day. Whatever the cause, it was clear that SWAN was not a stable traveler. To the scientists tracking it, this unpredictability was both fascinating and deeply unsettling. The comet seemed to pulse like a living organism, its every flare and shimmer hinting that something was building within, waiting to erupt. The anomalies emerge, weird behaviors. By late September, Comet SWAN's behavior had shifted from curious to alarming. On the night of September 26th, astronomers recorded a sudden outburst that caused its brightness to surge from magnitude 7.5 to about 5.8 within hours. To the naked eye, the change was subtle, but through telescopes, it was dramatic. The comet's coma expanded rapidly, and the inner regions glowed intensely, as if a spark had ignited deep inside. Such a sudden surge suggested an internal event, perhaps a collapse of the crust or a violent release of gas trapped under pressure. Yet, despite more than 20 days of favorable visibility, there was surprisingly little spectroscopic data to explain what was happening. No major observatory had released detailed composition analyses. For scientists, this absence of data was as puzzling as the outburst itself. It raised questions about what materials SWAN might contain and whether its outgassing involved unfamiliar compounds or rare metals. Some speculated that research teams were quietly studying it, holding their findings for peer review. Others feared it might reflect a gap in how humanity monitors potential cosmic threats. Either way, the silence surrounding SWAN's true makeup only deepened its mystery. Solar interactions. Just as astronomers were beginning to analyze the outburst, the sun erupted with one of its most powerful flares of the year. On September 28th, a massive M6.4 class solar flare launched a coronal mass ejection that traveled outward across the solar system. When that wave of plasma reached Comet SWAN, telescopes detected an immediate response. The comet's tail seemed to snap and twist, as if struck by an invisible storm. Within hours, sections of the ion tail appeared to disconnect completely, drifting away before gradually reforming. This phenomenon, known as a tail disconnection event, occurs when charged particles from a coronal mass ejection collide with the magnetic field around a comet. The surge of solar plasma can strip ions from the comet's tail and momentarily cut it away, leaving a temporary void before the new gases rebuild it. What made SWAN's reaction so interesting was its intensity. The tail did not simply bend or fade. It rippled violently, producing waves that moved along its full length. Some scientists describe the encounter as a cosmic dialogue between the comet and the sun. The same solar wind that powers Earth's auroras was now shaping SWAN's every motion. At the same time, space weather stations near Earth recorded a spike in solar wind strength, with readings showing a BT value near 18 nanoteslas and a BZ drop to negative 17. Though not directly linked, the timing suggested that comets like SWAN might influence how charged particles interact with Earth's upper atmosphere. If true, it hinted at an overlooked connection between distant cosmic events and the delicate electromagnetic balance surrounding our planet. Size and composition speculation. In the days following the solar flare, new questions arose about the comet's true size and structure. Online rumors claimed that SWAN was 100 times larger than previous interstellar visitors, like 3I Alta's, but astronomers quickly dismissed these exaggerations. The available data suggested a much smaller cavern nucleus, likely between 1 and 3 kilometers across, consistent with many long-period comets from the Oort cloud. What made SWAN appear so large was not its core, but the vast cloud of gas and dust surrounding it, expanding thousands of kilometers into space and reflecting sunlight with unusual efficiency. Comets are often described as dirty snowballs, a mix of rock, ice, and organic molecules. Yet, SWAN seemed to contain a particularly rich supply of volatile materials, which could explain its erratic flares of brightness. Each time sunlight struck its surface, jets of vapor burst through the crust, propelling debris outward like miniature explosions. Some astronomers speculated that it might contain traces of exotic compounds, such as sodium or iron, that intensified its green glow. Others suggested that its surface was unusually fragile, crumbling under the stress of solar heating. Whatever the cause, SWAN's unpredictable behavior hinted that it was far more complex than an ordinary block of cosmic ice. The hidden danger, potential asteroid risks. As Comet SWAN drew closer to the Sun, the growing concern among scientists was not just its strange behavior, But what might come next? When comets act unpredictably, they sometimes disintegrate. The heat of the sun can crack their surfaces and release trapped gas with such force that the nucleus splits apart. The result is a stream of rocky fragments that continue traveling along the same orbital path. Over time, these fragments can drift across Earth's orbit, transforming what begins as a spectacular celestial display into a potential meteor hazard. Comet Shoemaker-Levy 9 had provided a dramatic example of this process when it broke into pieces before colliding with Jupiter in 1994. SWAN's sudden flares and tail disruptions suggested that similar internal stresses could be building. Astronomers calculated that Earth would cross a section of SWAN's orbital plane between October 4th and 6th, 2025. While the probability of a direct impact was low, even a few surviving fragments could enter Earth's atmosphere, producing a brief meteor shower or, in a worst-case scenario, localized impacts. The idea that a beautiful comet might also scatter deadly debris gave new urgency to the study of SWAN's evolving structure. Closest approach analysis. By mid-October, Comet SWAN was racing toward its closest approach to the Sun. On October 20th and 21st, it would reach perihelion at a distance of about 0.26 astronomical units, or roughly 39 million kilometers. That distance placed it well within the orbit of Mercury, a region of intense radiation and solar wind. For a fragile comet, this was a perilous journey. Many comets that venture this close do not survive. Their icy cores expand, fracture, and sometimes vanish completely in a burst of gas and dust. Astronomers compared SWAN's situation to that of C/2025 Atlas, another visitor making a close pass through the inner solar system around the same period. The presence of two large comets traveling through the same region within weeks of each other raised questions about the stress such events place on current planetary defense systems. Monitoring one active object is challenging enough, but tracking multiple bodies with unpredictable behavior pushes the limits of observation networks and data-sharing systems. Some researchers speculated that if SWAN fractured after perihelion, a swarm of small asteroid-like fragments could remain in orbit for years. These fragments might gradually spread along its orbital path, creating unpredictable intersections with Earth's trajectory far into the future. Although such a scenario was not considered an immediate threat, it underscored how little is known about how comets evolve after they pass close to the Sun. The lingering debris could persist for decades, silently orbiting, waiting for gravitational forces to nudge them onto new and potentially hazardous courses. Historical parallels. Throughout history, humanity has watched the skies with both awe and fear whenever a bright comet appeared. Ancient civilizations often saw them as omens of change, disaster, or divine wrath. Yet beyond superstition, comets have occasionally proven to be true harbingers of destruction. The Tunguska event of 1908 in Siberia, for example, is widely believed to have been caused by the explosion of a cometary or asteroidal fragment that flattened more than 2,000 square kilometers of forest. Though it never struck the ground, the airburst released energy equivalent to 15 megatons of TNT. Other historical parallels provide sobering context. In 1490, records from China describe a stone rain that killed thousands near the city of Qingyang, possibly caused by the breakup of a comet or meteor cluster in the atmosphere. More recently, the 2013 Chelyabinsk meteor reminded the world that space debris can arrive unannounced. That object, only about 20 meters wide, injured more than 1,000 people through shockwaves and shattered glass. These events reveal a pattern that astronomers cannot ignore. A single unstable comet, if fractured, can seed Earth's orbital neighborhood with countless small but dangerous fragments. Comet SWAN's unpredictable behavior and tendency to flare unexpectedly echoed the same precursors seen before other fragmentation events in history. While modern technology offers improved early warning systems, history has shown that even a brief lapse in monitoring or a single miscalculation can turn a cosmic spectacle into a sudden catastrophe. Truth amid the stars, scientific perspectives, and conclusion. As public fascination with Comet SWAN intensified, social media platforms became flooded with speculation. Some users claimed that the comet was fragmenting into several large pieces that could strike Earth. Others suggested it was not a comet at all, but an unknown asteroid entering the inner solar system under the guise of a cometary tail. The growing confusion pushed astronomers to clarify what was actually happening. Dr. Jessica Nguyen, a cometary physicist at the European Space Agency, explained that SWAN's erratic brightness was not evidence of impending collision, but rather a sign of volatile ices sublimating unpredictably. When sunlight hits the nucleus unevenly, gas jets erupt, throwing dust into space and creating bright outbursts. "It is alive in the way comets often are," she said during a press briefing, "but there is no indication of an Earthbound fragment." NASA's Near-Earth Object Observation Program released a statement confirming that none of SWAN's projected orbits intersected Earth's path within the foreseeable future. Radar and optical data showed a safe margin of several million kilometers during its closest approach. Experts from the International Astronomical Union also debunked claims that its twin, Comet Atlas, posed any joint threat. Both were following distinct orbital trajectories, shaped by centuries of gravitational interactions. Despite this reassurance, researchers acknowledged that SWAN's strange activity had provided valuable data. Its flares, composition changes, and solar interactions offered clues about how dynamically unstable comets behave near the Sun. Rather than being an omen, SWAN became a scientific case study on the limits of cometary endurance and the fine line between brilliance and disintegration in the harsh environment of space. As Comet SWAN faded into the outer solar system once more, it left behind more questions than fear. The world had witnessed how beauty and danger can coexist in the same celestial body, how a trail of light across the sky can inspire both wonder and anxiety. Scientists continue to analyze its data, tracing the intricate dance between ice, rock, and sunlight that shapes every comet's journey. For astronomers, SWAN was a reminder that humanity still stands at the edge of knowledge, gazing upward at a cosmos filled with unpredictable forces. It also highlighted the strength of global cooperation in space observation. Across continents, observatories shared findings in real time, using the event to refine models and strengthen planetary defense readiness. The experience demonstrated that while fear may spread faster than fact, truth, once clarified, has the power to calm and educate. In the end, Comet SWAN was neither a herald of doom nor a simple curiosity. It was a mirror held to humanity's fascination with the unknown. Its sudden appearance, wild flares, and mysterious behavior rekindled a timeless truth: that the sky above is not static, but alive, a vast and restless sea where each spark of light tells a story of creation, destruction, and the unending pursuit of understanding. As Comet SWAN fades into the vastness of space, what remains is not fear, but fascination. The universe reminds us that we are part of something immense, unpredictable, and still largely unknown. Every comet, every flare, and every fragment tells a story billions of years in the making. While scientists continue to watch the skies for signs of change, we are reminded that vigilance is not born of fear, but of curiosity and respect for the cosmos. Whether Comet SWAN was a warning, a mystery, or a mere spectacle, It leaves us with a single truth. The sky above is alive, and our quest to understand it is only just beginning.